Alright, welcome back everybody. This lesson is a review lesson on net change in area. And we're going to break down and look at a few examples over the course of 3 videos in this particular lesson. We're going to start with net change type problems. These have become pretty frequent on our AP exam, and I say here they should be easy points for anyone who's prepared for them. Let's look at the first situation. We're told that the velocity of a particle moving along the x-axis with known position x of 2 equals 5 is described by the equation velocity of time is equal to t squared plus the natural logarithm of t for all t greater than 0. Where is the particle at t equals 5? So, in order to answer a question like this, we're going to use the same general concept every time. We're going to be looking for location of something at specified time. Let's say location at specified time. We're going to know a location at some original time. Let's call it location at known time. And we're going to add to that the integral from known time to specified time of the velocity function with respect to t. And that's going to give us the location at the specific time we're looking for. So we're looking for where it is at 5. We know where it is at 2. And so we're going to add to that the integral from 2 to 5 of the velocity. And now in order to find the position at time 5, all I need to do is perform that calculation. We know that it's at location 5 at time 2. We're going to take 5 plus the integral from 2 to 5 of the velocity function. And I'm going to go ahead and use my handy-dandy calculator to do that. So I've got 5 plus, I'll grab my numerical integral. And of course our calculator is going to use x as the variable instead of t. We want the integral of x squared plus natural logarithm of t with respect to x from 2 to 5. And that gives us that the location here of this particle at time 5 is going to be 47.661. Okay, easy enough. Let's look at example 2. Example 2 comes directly from the 2012 AP Calculus PC exam. Question number 2. This was a calculator question. So we have all this information about a particle. We're asked to find the x-coordinate of the particle's position at time t equals 4. We know the x-coordinate at time t equals 2. Time t equals 2, particle has an x-coordinate of 1. So in order to get the position at time 4, we're going to take position at time 2 plus the integral from 2 to 4 of dx dt, which in this case is square root of t plus 2 over e to the t. And so now I'm going to calculate that. And so I've got 1, since that's the x-coordinate, plus the integral of the square root. Again, my calculator is going to use x in here, over dx with respect to x from 2 to 4. And we get that location is 1.253. And we're done. that's how net change problems work. And like I said, if you recognize a problem as a net change problem, the actual skills that you need to calculate it are relatively simple. But there it is. Alright, that's the end of this video. See you guys next time for some more applications on reviewing area.